Good afternoon, students. Um, this class will be handled with digital image processing concepts. This course objective is to get familiar with the image acquisition process and the color image processing model. And then another objective is to analyze the functionalities of facial and the frequency filters for manage image enhancement, and also to investigate the various edge detection models and the different applications, and also to learn the concept of image compression and analyze the various compression techniques to identify this requirement of various image segmentation methods and object recognition models for various real-time application. In this first unit, we say there's so many fundamentals of digital image processing. They like that image sensing and acquisition, and image sampling and quantization, relationship between the pixels and the random noise, Gaussian Markov random field, and the sigma field, linear and non-linear operation, image processing models, casual and semi-casual, non-casual models, and the color models of image processing, like that color fundamentals, color models, and then pseudo code color image processing model, full color image processing, and the color transformation and the noise in color images. So these are this second unit and third unit, fourth unit and fifth unit. First I will teach about this unit number 1. There are two textbooks are there. So especially that we just say here, first book is Rafael Gonzalez, Richard Keywood, the based on digital image processing, fourth edition, PHI PSN edition in the year 2013. AK Jain, and then author of Fundamentals of Image Processing, second edition. There are two textbooks are there. The first in concept will move to the first thing is we come to image fundamentals. That is sensing, image sensing and acquisition. Let us move to this digital image processing. The based on this digital image, there are so many concepts are there. The first to define the scope of field that we call image processing, to give you a historical perspective of the origins of this field, and then what is this art in image processing by examining some of the principles areas in which it's applied, and finally come to the principal approaches used in digital image processing and overview of the components of typical general purpose of this image, and to provide the direction to this literature where the image processing work is reported. So these are this main concept of image processing information. So like that, what is image? So image may be defined as a two-dimensional function, especially f of x comma y, denoted as f of x comma y, where x and y are spatial. Is another name is called plane. Spatial means plane coordinates, and the amplitude of this f at any pair of coordinates is called x comma y. So the intensity or gray level of the image at the point, will when this x and y, we say this the either f for all the finite or discrete quantity. So in this say the image is called digital image. So this image will come to, normally will come to say this the type of gray level intervals. So these elements are called picture element, image element, or pels or pixels. So pixels is the terms used most widely denoted as the element of the digital image. So these are the main fundamental. So another one, you'll come to electromagnetic spectrum to identify this different type of waves is there. So in this say this origin of the digital image processing, this is the first thing, a digital pictures produced by in year 1921 from this coded tape by the telegraph printer, the special typefaces. That means Macfarlane. Macfarlane is this biography. I will come to this produced from first digital picture in year 1921. A digital picture is made in 1922 from this tape punched after the signal had crossed the Atlantic twice. That's Macfarlane. These are this image. Another picture says retouched cable picture of General's Pershing, this right and forged of transmission year 1929 from London to New York by 15 ton equipment, another courtesy from Macron. So these are just a major role to be come to this history of year 1948 and 1960, 1981 and 80s. That is a generation of this new large scale integration, the very large scale integration VLSI introduction, and then ultra large scale integration. Develop the type of this new innovative of this digital pictures. So in here, the first picture of this moon by US spacecraft Ranger 7 took this picture on July 31st in the year 1964. So many medical based diagnosis of image modality X-rays sources also be developed here. Ni- 1895, Wilhelm Conrad Röntgen in the year 1895 is received from 1901 from Nobel Prize of this physics, X-ray. So these are the examples of fields that is we using from digital image processing. So these are the main electromagnetic rays. You will come to this say here this is a visible range 10 power 0 human visible range, and then both negative and positive range. Negative side you will come to infrared microwaves and the radio waves, and the positive side you will come to ultraviolet and X-rays and gamma rays. So everything from energy of one photons from electrovolts. So gamma ray imaging, X-ray imaging. I'll say this that a particular type of this Poisson emission triode. The type of this is bone scan images, and also this is NASA and satellite pictures from the type of images will come to this X-ray. Sample of X-ray imaging like that chest X-ray, aortic angiogram, and head CT, circuit board, and Cygenus loops of this image, different like that different type of images. This computer axial tomography CAT will come to this another type of this image will come to produce imaging in the ultraviolet bond. Ultraviolet like that the type of this example of image normal cone and a cone infected by this smudge, and then Cygenus loops will come to say this the type of different type of ultraviolet imaging. So imaging in this visible from infrared band, we will come to examples of the light microscopy images, Taxol, that is this cholesterol range. You will come to the say here microprocessor, nickel oxide thin film, surface of audio CD, organic superconductor. So these are these pictures will come to say this another type of nozzles will come to producing from the different type of ranges in between this wavelength 0.45 to 2.35 up to the different type of visible blue up to shortwave infrared. So these are this satellite image of Hurricane Katrina takes on the year August 29, 2005. Courtesy of this NOAA, that is the importance of this infrared imaging. So another infrared satellite imaging of this Americas, the small shaded map is provided for this reference. Courtesy of NOAA. That is a spectrum of infrared, the populated of this all the parts of the world. These are the satellite pictures. So most of the imaging in this microwave band will come to like that the type of this sample of example of micro manufactures goods checked using digital image processing. That what are the defects will become to aggregate in this particular circuit. Imaging in this another type of radio band will come to analyzation from additional examples of imaging in this visible spectrums, thumbprint, paper currency, and also and the both C&D is that is automated license plate reading. So you will come to this analyzation from the type of image processing field. So another type of image modality we like that is space-borne radar, image of a mountainous of regions in the southeast Tibet. Another type of MRI images, magnetic resonance images of human knee and spine. Will come to courtesy of this Dr. Thomas or just a division of anatomical sciences. Images of a graph plus pulsar in the center of this each image. Cross sectional of image of this sesamal models. The following there's so many type of this image we come to say this examples of ultrasound imaging like the fetus and then another view of fetus and the thyroid or muscle layer showing for lesions, and this is the main culture of the Siemens medical systems incorporation of ultrasound groups. So this is a transmission electron microscope TEM. You come to another type of this analysis of SIM image analyzation from the type of a thermal failure. The fractal image like that the type of this image generated from this 3D computer models of the object shown. So here this is courtesy of this Miss Melissa T. Wilde and Swather Moore of this college, the courtesy of this NASA come to analyzation from the type of one. Another one you come to say this a fundamental steps in image processing. So major role of image acquisition and image enhancement, the role of the study of this structure like that is fundamental steps to in the digital image processing. Like this, a knowledge base. First one is the image problem domain. You come to analysis for image acquisition, and the image filter and enhancement is a pre-processing work. And next level is the image restoration. Another one is the color image processing, wavelet and other image transformation, and the compression and watermarking, morphological process, segmentation, feature extraction, and image pattern classification. So these are this output process generally or image. So in this four process like that output of this process generally or the image attributes. So like that it will come to move from the next level of image processing techniques. So what are the main components of this image processing system? Like that here say so many components are there. So first components will be cloud to be connected with this internet network area. So here say this is a computer, image display, mass storage, hard copy, specialized image processing hardware, image processing software, and image processing sensor. Like that, this is the problem domain. So you'll come to this. What are the most components you'll come to, like from in this image processing techniques. So these are the first fundamentals. Now this digital image fundamentals area. Like that, after digital image, you'll come to say the so many type of visual perception, and then majorly that the human eye is one of the visual perceptron of this human eye. In this say this type of the human eye because the cross of a human eye cross section, the calibrate body and the lens, the anterior chamber, the cornea, and then iris, and then ciliary muscles, fibers, and the visual axis, and the vitreous humor, and the retina, and the blind spot, fovea, and the scleria, and the cordial. So these are this is nerves and snakes are there. We'll come to this is the cross section of this human eye. In this say here, this is the type of distribution of rods and cones on the in the retina. The blind spots, what is the blind spots will be based on this angle 0 degree to 80 degree, both left and the right side. So image formation this eye, you come to study about this is what is the brightness and the darkness. Here to say this a type of this graphical representation of eye looking at the palm tree. Say this the point C is the focal center of this lens in reverse of this portions like that the type of this brightness of this role. So in this range of the subjective brightness sensitization showing this particular adaptation levels. So majorly we'll come to like that is a image sensing area of this digital image processing. So what is the major role for digital image fundamentals? So in this light and electromagnetic spectrum, we already discussed about this visible range to positive to negative from this electromagnetic spectrums. So wavelength is we say this a lambda, frequency is a mu. That is we say this a type of the relationship. Lambda equals C divided by V. The frequency will come to electromagnetic spectrum like this expression of energy S into V. So electron volts from each and every one photon. Frequency is the representation of the unit is called hertz. Wavelength is the representation of unit is meters. So in this visible range, you'll come to say that the type of the different range of colors are there. Infrared, red, orange, yellow, green, blue, and violet and ultraviolets. So in this range, you'll come to say the type of graphical representation of wavelength. So the first topic will come to the after the fundamentals, image sensing and acquisition. So what is the major role from image sensing? We enclose illumination and scene in the course of emphasize that is considerably for more general than which one will come to say this minimum level of this illumination familiar of 3D scale. So in this electromagnetic energy such as the radar, infrared or X-ray system, we'll come to see the type of this illumination pattern, the computer generated from illumination pattern. The like that the type of this any type of image modality, say this X-ray or any type of ultrasound, any type of images, will come to say the different type of waves will come to produce in this the particular uh, devices. So in image acquisition using a single sensing element, so what is the major role from that sensing element? That is a photodiode. The constructing from silicon materials and whose the output of voltage proportional to light intensity. In order to generate from 2D image using the single sensing element, there are to be a relative from displacement of this x and y directions. So in these cases, you'll come to micro densitometers. Will come to analyzation from the type of sensing elements. So here say this a power in. This is a sensing material for a single sensor. In this filtering range, that is this energy will come to passing through this a different type of sources. Here this is housing and then voltage waveform. This is a single sensor. This is a line sensor. The second picture should be noted, come to line sensor, same element. So third element will come to say this array sensor. There are three different type of sensing element: single sensing element, line sensing sensor element, and then array sensor element. Array means both rows and columns. So this is a combining from single sensing element with the mechanical motion to generate a 2D image. So based on the sensor and the rotation and the frame, linear motion, one image to line out from per increment of rotation and the full linear. Image acquisition using sensor strips, a geometry used more frequently than single sensor is an inline sensor strip. As in this figure, we say this is the type of image sensor node. We will come to say this is the type of image acquisition using a linear sensor strip. So in this image acquisition using circular sensor strips, we will come to say the type of the cross-sectional images from 3D object. Say in this linear motion that is called a 3D object, the sensor ring will be come to rotation from the source rotation, the X-ray source, that is this image reconstructions among the particular strips. Here this image area, sensor strip, linear motion, and then one image to line out per increment of linear motion. So these are the main thing from sensor units. So in this image acquisition using sensor arrays, charge coupled device CCD from 2D array. So like that 4000 elements or more will come to each and every CCD charge coupled device sensor are used widely in this digital camera. So on the other light sensing instrument, the response of each sensor is proportional to this integral of this light energy. So in this case, so many sources of image directly as obtained from the images of sun. We'll come to this based on the illumination. We say sun energy come to produce 90,000 luminance, and the day light in night time will come to produce 10,000 luminance only. So based on this image, we'll come to change over this energy of sensing of this light. A simple image formation model, for example, f of x comma y, is a two-dimensional functions of this form, where the value of f at a spatial coordinates x comma y is a scalar quantity whose the physical meaning is determined by the source of the image and whose the values are proportional to energy radiated by this physical source. So example, electromagnetic waves. As a consequence of f of x comma y must be the non-negative and finite, that is will come to energy to be forced in this particular example of the digital image acquisition. First, this is a scene. This is the illumination energy of the day or night source. There is an imaging system. Suppose I will come to internal plane. That's the output of digitized image. That's the digitized image. So the C is the image systems. So what is the real picture will come to acquire in this picture, but finally got this digitized image. Like that, it will come to the say formula 0 less than or equal to f of x comma y and less than infinity. There are two components to be like that: the amount of the source illumination incidence of this scene being viewed, and two, the amount of illumination reflected by the scene of this object. So appropriately, these are called illumination and reflections of the component, and then denoted by I of x comma y and r of x comma y respectively. The two functions will come to combine with f of x comma y. You say this f of x comma y equal to I into I of x comma y into r of x comma y, where 0 is less than or equal to I of illumination, that is of x comma y less than infinity, and 0 or less than or r is reflectance x comma y less than or equal to 1. So reflectance is bounded by 0, the total absorption, and 1 is the total reflectance. The nature of I of x comma y is determined by the illumination source, and r of x comma y is determined by the characteristics of the image object. So these objects will come to majorly will come to transmitting of this reflecting of this value. So these are the main thing you will come to say this the type of some typical values of illumination of reflectance. The example will come to say this 90,000 luminance per meter square will come to the day night day at the daytime, and the night time will come to 10,000 luminance per meter square. Say the type of this formula will come to change over from flat white wall paint and then snow. You will come to change over from this the type of a monochrome image. So you'll come to L equal to f of x comma y, and then the intensity level will come to change over from L minimum and L maximum. You'll come to say this both of will come to negative value. The type of this value will come to say here L minimum comma L maximum. In this case of the intensity of the scale from common practice is the shift this interval numerically to this interval 0 comma 1 and or 0 comma c, where this L equal to 0 is considered from the black and L equal to 1 is or c. You will come to say this the type of a white. Will come to shadow off from white, black to white. So next topic will move to image and sampling and quantization. Will discuss will be